This lesson is about properties of rectangles. So I'm guessing you're probably already familiar with rectangles, but some of these properties may be new to you. If you didn't already know, a rectangle is a quadrilateral, so a four-sided shape with opposite sides congruent. So in this picture, segment HJ is congruent to segment KL, and segment HK is congruent to segment JL. What you might not have already known is that rectangles are actually parallelograms. So everything we learned about parallelograms applies to rectangles. I've got a big list of rectangle properties down here. Everything you see on the left is actually a parallelogram property. So that is not new. Anything we've talked about in the last couple lessons can apply to rectangles. And then what I added on the right is things that just apply to rectangles, not to all parallelograms. So I'm going to speed through this list on the left. And if you want a more in-depth look at what these things mean, go back and watch the parallelogram video. So in a parallelogram, opposite sides are parallel. That's the definition. So in this picture, segment HJ is parallel to segment KL, and segment HK is parallel to segment JL. Second thing we know is opposite angles are congruent. Opposite just means across from each other. So angle H and L are congruent, and angle J and K are congruent. Then we know opposite sides are congruent. I already pointed that out to you. That's part of the definition of a rectangle. Fourth, we have consecutive. Angles are supplementary. Consecutive just means next to each other. So angle H and K are next to each other, so they add up to be 180 degrees. Along the bottom, K and L are next to each other, even though they're still pretty far apart. So those two angles are supplementary. And then our last parallelogram property is that the diagonals bisect each other. So diagonals are just lines connecting vertices inside of a polygon. So those are my two diagonals. And bisect means to cut in half. So those two segments are congruent, and those two segments are congruent. All right, and then properties that just apply to rectangles, not every single parallelogram, would be that all four angles are right angles. You probably already knew that, but in a rectangle, all of the angles are 90 degrees. And then our last property of rectangles is that the diagonals are congruent. So this wasn't necessarily true of just any old parallelogram, but it is true for rectangles. So since our diagonals are congruent and our diagonals are bisected, we could actually say that each short section, so each like half diagonal, is congruent in a rectangle. All right, let's apply these properties. This should go pretty quick because it's just what we've been doing with parallelograms. We just added two new things to our list. So ABCD is a rectangle. I'm going to find a couple of different things. If AE is 36, so the distance from point A to point E is 36 units, and CE, so that's the distance from C to E, is 2x minus 4. Find x. Well, in any parallelogram, not just a rectangle, we know that the diagonals bisect each other. So AE and CE will be congruent. So I just have to do a quick algebra problem. We know 36 should equal 2x minus 4. Add 4 to each side. 40 equals 2x. Divide each side by 2. X would be 20. And I'm going to use the same rectangle A, B, C, D for the next two problems. So I'm just going to erase the work that I already did. If BE, so the distance from point B to point E, is 6y plus 2, and CE is 4y plus 6, find y. So we know that since this is a parallelogram, the diagonals bisect each other. We know that since it's a rectangle, the diagonals are congruent. So that means from that point of bisection out to any of the vertices would be half a diagonal. And since the diagonals are the same, the halfway diagonals are also going to be the same. So we know that segment BE is going to be congruent to segment CE. In other words, 6y plus 2 equals 4y plus 6. I'm going to start by subtracting 4y on each side. So that'll get me a 2y. And I'll subtract 2 on each side as well. So I'll get to 2y equals 4. And then I'll divide by 2. So y is 2 in that situation. All right, and then our last example in a rectangle. If the measure of angle BEA, so that goes from point B to E to A, that's going to be this angle, is 62. Find the measure of angle BAC, B to A to C. This is what I want to find. So this is kind of a tricky one because we usually need two angles of a triangle to find a missing angle. But since we know that the diagonals are congruent and that the diagonals bisect each other, I know that this segment, so BE and AE, have to be congruent. Well, those two congruent segments with segment AB form an isosceles triangle. Way back at the beginning of the year, we learned something called the isosceles triangle theorem or the base angle theorem, which said in an isosceles triangle, the two base angles are congruent. So if I can find one of those angles, I'll know both of them. Angles inside of a triangle have to add up to be 180 degrees. So for now, let's call both of these x. We know that x plus 62 will equal 180. I'm going to subtract 62 on each side of this equation. So that would get me to 118. I have 2x left over there. Then to solve for x, I could just divide by 2 on each side. 118 divided by 2 is 59. So the measure of angle BAC is 59 degrees. And I just pulled out one isosceles triangle there, but you can do the same thing like in the top of the rectangle or in the bottom. That's an isosceles triangle. Again, you've got a matching one down here. Or we've got one over here.